Okie dokie, welcome back to the shed. Right, nice windy, well, rainy night tonight. Anyway, we're in here, nice and safe. Okay, so I got here a Sea Dog sail, made here in Australia. This one's a 0.8 and 0.6 square meter sail. It's got reefing eyelets along one of the battens, so you can close it up to 600 centimeters, etc., etc. Okay, so this is how you mount the bastard. This little doohickey. Okay, so this little doohickey goes in that doohickey. Right there. Keep your minds out of the gutter. Alright. So that sucker goes there, and then this piece goes on the deck, like so. Or, I've seen in other videos, like that. Now, I don't like that way. I'm going to put it that way. Now, this Sea Dog sail is going to be, the sail mount will be always mounted here. And I've got a lateral stay either side. So you've got a port stay here and a starboard stay there, like rope lines, guide lines. And you've also got the uphaul line that's going to be over there. So at no stage will the strength need to be here, but the mast will always collapse down onto the cockpit, like about there. Like so. So I can still paddle. I have clearance for my normal stroke. And it just goes across the top of my toes, which doesn't impact on it. And it sits up on the gunnel. Okay. But all the flex will be orientated here, like that, continually. When you put it down, it will flex. When you put it up, it will straighten up. When you put it down, it will flex. So, me being a practical sort of dude, that means this mast is always going to have a lot of strain, lateral strain and pull strain, doing that all the time. So what I don't want is it to be orientated like that. I'd rather the mount be tensioned and strained along its axis, which means I'm going to mount it like that. Now, it's a little bit wonky. That's a technical term for it being convex. Okay, so I've had to make this up here. So I'll put that down there. This little doohickey I made up tonight. What it is I carved the groove in, and then I flattened off the back edge after I heated it up and curved it. So I had to carve it on this side, curve it, check it, and then get the back edge straight again. So this little doohickey, when you put it on the deck, sits flat and flush, and the mast mount goes straight through that. So we've got a 0.8 of a millimeter polypropylene mount, or polycarbonate, like HDPE. And then I've got M6 35mm stainless gear going straight through both of those. And underneath, I will have over here, I will have a larger plate curved to the inside of the deck, being concave. So convex on the outside, concave on the inside. I'm basically going to repeat that curve, but I'm going to make it much larger. So basically, I'm going to utilise about this much room underneath, Sikaflexed, and double stainless hardware going straight through it to the underside of the deck. So it disperses the load evenly around this whole hatch bulkhead area. And then I'll have the stainless steel hardware going through these two, straight through the underdeck, straight through the actual the support on the deck, which is about yay wide by yay. And that way, any lateral load or flexural strength will be markedly increased by using the cutting board. So, there you go. Little doohickey. That is a better option from what I've seen other places. So, when the sail kit goes down and back up again, the torsional load will be axis along the mast. So therefore, I'm going to orientate the hardware along the axis of the line of the load, not across. That doesn't really impress me, but I'll gain 10 times more actual axis flexural strength if I just run it along the mast line. So there you go. That's taken me all afternoon. Now you'll have Fridays. Okay. All right, have a good one. Keep your fluids up, and I'll talk to you on. Okay, that's my take on a kayak sail mount plate.